Hello students. In this session, we'll be discussing the chemistry of diethyl malonate. Okay, so we have already started our discussion on organic synthesis via enolates. So in this session, we'll be discussing about the diethyl malonate. See, what is diethyl malonate? Diethyl malonate is also referred as malonic ester. Okay, the structure of diethyl malonate is CH2 C double bond O OC2H5 C double bond O OC2H5. So this is diethyl malonate. Okay, it is an ester, C double bond O. It is an ester of malonic acid. Okay, malonic ester is also it is referred as. So in this session, we will be discussing the preparation of this diethyl malonate. Then we'll be discussing about the reactions or its synthetic application of this in synthesis. Okay, let us discuss the preparation. Malonic ester can be prepared conveniently by boiling sodium or potassium cyanoacetate with alcohol and concentrated HCl. Okay, so it can be prepared from sodium or potassium cyanoacetate. So what is this potassium cyanoacetate or sodium cyanoacetate? Is CH2 COO minus K plus. Okay, cyanide. So CH2 actually CH3CO minus is acetate, since one is linked to this cyanide group. So CH2CO minus will be acetate. So potassium acetate, there is a cyano group. So this is potassium cyanoacetate. Okay, this when treated with alcohol and concentrated HCl what happens is it. So what happens is, first this molecule undergoes hydrolysis. The cyanide undergoes hydrolysis to form acid. So in presence of water and HCl, what happens is this cyanide undergoes hydrolysis and it forms corresponding acid. So you get this molecule CH2 COOH. Cyanide gets hydrolyzed to acid COH, plus the side products obtained are potassium will react with Cl to form KCl. This is one side product that is obtained. So another side product, that is nitrogen, goes as NH4Cl. So it will be 2 molecules of water, 2 molecules of HCl. So this is what is happened. Okay, in first step, what happens is this cyanide undergoes hydrolysis to form corresponding acids. So we got malonic acid. This is malonic acid. But we are targeting the preparation of an ester. That is, we are targeting the preparation of malonic acid ester, since this acid group should be converted into ester. So hope you know acid can be converted into ester by treating it with alcohol, and that reaction is called as an esterification reaction. So this malonic acid CH2COH COH in presence of ethyl alcohol and HCl, the reaction is catalyzed by HCl. So undergoes esterification to give you COOC2H5 COOC2H5. So you get diethyl malonate is what you get. You get diethyl malonate. Okay, so the preparation of diethyl malonate occurs in 2 steps. So it can be prepared from cyanoacetate, potassium cyanoacetate. So in first step, it undergoes hydrolysis to form corresponding acids. The acids are converted into ester by esterification reaction. So hence this molecule, that is cyanoacetate, potassium cyanoacetate, when it is boiled with alcohol and HCl, so gives you diethyl malonate. So the reaction occurs in 2 steps. First step will be just the hydrolysis of cyanide to acid, and then second step will be esterification that will be taking place. So we will get the required product, that is the diethyl malonate is what we are going to get. Okay, this is the simple preparation. Let us discuss now uh, the synthetic applications of this diethyl malonate. So diethyl malonate can be used in preparation of carboxylic acids. So since it is an ester, so it can be used in preparation of acids. Okay, malonic ester can be converted into monoalkyl derivative by heating it with sodium ethoxide and alkyl halide. The product obtained is subjected to hydrolysis, which will give you monoalkyl carboxylic acid. So let us discuss the synthetic application of that. The first one is in the synthesis of. First one is the synthesis of monoalkyl carboxylic acid. Monoalkyl carboxylic acids. Okay, so this can be prepared from the ester, that is the malonate ester, malonic acid ester. So CH2 COOC2H5 COOC2H5. This is the ester that is okay. This is treated with ethoxide, sodium ethoxide. So this sodium isotoxide removes this proton because this proton is acidic in nature. The proton is acidic in nature, so it removes that proton. So it abstracts the proton. So the proton is abstracted. So a carb anion is generated. Minus Na plus. So monosodium salt is obtained. Okay, so this hydrogen is acidic ester. Hope you remember in case of ethyl acetate also this methylene group hydrogens were acidic. So this because they are in between the two electron withdrawing groups. So this is acidic. So when it is treated with sodium ethoxide as a base, it abstracts this proton, resulting in the formation of a sodium salt. This sodium salt is treated with an alkyl halide, that is RX. So you know that in an alkyl halide, halogens are electronegative, so they acquire a slight negative charge, and this carbon acquires a slight positive charge. So this negatively charged carbon attacks this carbon and forms a bond, expelling this X minus. So there will be a bond between this carbon and this alkyl part. So it results in the formation of this compound. So it will get RCH COOC2H5 COOC2H5. This is what is it. So RCH COOC2H5 and COOC2H5 is what is obtained. Okay, now so we want carboxylic acid. So this is an ester. So this ester on hydrolysis, basic hydrolysis followed by acidification will give you acid. See, esters are formed by reaction between acid and an alcohol. Acid and an alcohol will give you ester plus water. So esters when hydrolyzed will give you back to acids. So this is subjected to hydrolysis. KOH water, and next it is subjected to acidification. Okay, will give you back the ester, will give back the acids. So what you get is you get this molecule RCH COOH COH is what is obtained. See, acid plus alcohol will give you esters. Okay, acid plus alcohols will give you esters. So esters when hydrolyzed will give you acids. So since this is a base, you get a potassium salt. So on acidification you get the carboxylic acid. But we are targeting the monoalkyl carboxylic acids. So what is done is next this is heated. On heating, this undergoes decarboxylation. removal of carbon dioxide takes place, resulting in the formation of RCH2COH. This is what is obtained. So you get carboxylic acid. So students, so we have an ester. First the ester is converted into acid. So before that, you can alkylate it, okay, by treating it with alkylate. You get an alkylated ester. So then the ester is converted into acid by simple hydrolysis, and there are two carboxylic acid groups. Then on simple heating, it undergoes decarboxylation to give you an acid. So this is the preparation of acid from malonic acid ester. Similarly, you can prepare a dicarboxylic acid also. You can prepare a dicarboxylic acid. Example is the succinic acid. Okay, so malonic acid ester can be used in the preparation of dicarboxylic acid, that is succinic acid. Hope you know the structure of succinic acid. We have already discussed in ethyl, while the synthesis of succinic acid by using ethyl acetate. Okay, so you can even prepare this by using malonic ester. CH2 COO C2H5 COO C2H5. First it is treated with sodium ethoxide. So base abstracts the proton, resulting in the formation of CH minus, COOC2H5, COOC2H5, and Na plus. It abstracts the proton, resulting in the formation of a monosodium malonate, or an carbanion is generated. This is treated with chloroethyl acetate. This is ethyl acetate. Chloroethyl acetate. Chloro, slight negative charge, halogen, more electron, this slight positive charge. So this anion attacks this carbon, expelling this. So you get this compound CH, COOC2H5, COOC2H5 is what is obtained. This attacks this carbon, so this new bond will be formed, that is CH2COOC2H5 is obtained. Okay, so Na will combine with Cl to form NaCl and it goes off. So you can even write it as minus NaCl. Okay, next, it is hydrolyzed. Acid hydrolysis. So on acid hydrolysis, ester gets converted into corresponding acids. You know that esters on hydrolysis will give back acids, so you get acid. So what happens is you get this compound CH, COH, COH, CH2, COH, CH, COH, COH. This ester gets converted into acids. Okay, then it is heated, it undergoes decarboxylation, okay, resulting in the formation of CH2COH, CH2COH. Same, the previous what we have solved, same method. The only difference is here we are using chloroethyl acetate. There we used simple alkyl halide. Okay, so you get a dicarboxylic acid, and this dicarboxylic acid is succinic acid. Okay, this is the use of malonate, diethyl malonate, okay, in synthesis of monocarboxylic acids and dicarboxylic acids. Okay, now let us now discuss the use of this ester in preparation of ketones. Okay, first keto acids are prepared, and next those keto acids on decarboxylation will give you ketones. Okay, let us take this malonic acid esters. CH2, C2H5, C2H5. Okay, it is treated with sodium ethoxide. Abstraction of proton takes place. CH minus Na plus CO C2H5 C2H5. Okay. Next, this is treated with acetyl chloride. What is this acetyl chloride? It is CH3CO Cl is acetyl chloride. CH3CO Cl is acetyl chloride. It is treated with acetyl chloride. Okay. So what happens is this anion attacks this carbon, expelling the Cl. So a new bond between this carbon and this carbon is formed. Okay, resulting in the formation. I'll write the structure of that. It is CH, CO, C2H5, CO, C2H5, this carbon and this carbon, that is C double bond O, CH3. Okay, this is subjected to hydrolysis, acid hydrolysis, and you know that on acid hydrolysis this ester gets converted into corresponding acid. So what you get this compound CH3, C double bond O, CH, COOH, COH. This is what you get. Okay. This on decarboxylation. If you just heat it, it undergoes decarboxylation. So resulting in the formation of this compound CH3, C double bond O, CH2, COH. Okay, this is called as a keto acid. The name of this is acetoacetic acid. This form. Simple. Sodium ethoxide, you know what sodium ethoxide actually does? It abstracts a proton. Then it is treated with acetyl chloride. This carbon attacks this carbon because this is the positively charged carbon expelling Cl. So a new bond is formed. Then it is converted into acid by simple hydrolysis. And then on heating it undergoes decarboxylation to give this. But we are targeting the synthesis of ketones. So this molecule on further decarboxylation, this molecule, I mean this one, it is keto acid, CH3, C double bond O, CH2, COH. On further heating undergoes again decarboxylation to give this compound. A ketone is formed. This is an acetone. This is an acetone. Okay, this is the method of preparation of ketone by using diethyl malonate. Okay, so this is the applications in preparation of acids as well as ketones. Now the last one, that is application of this diethyl malonate in the synthesis of heterocyclic compounds. Hope you know what are heterocyclic compounds. So in synthesis of heterocyclic compounds. Now, so malonic ester on condensation of with urea gives an barbituric acid. So hope you know what is urea. So let me write first the malonic acid ester CH2, C double bond O, OC2H5, C double bond O, OC2H5 plus urea, that is NH2, CONH2. Condensation takes place this plus of this. Okay, so minus 2C2H5 OH. Okay, so malonic acid ester undergoes condensation with urea to form the heterocyclic compound. So just write the structure. Okay, it will be this CH2, C double bond O, C double bond O, this one, then NH, the new bond is formed, C double bond O. So this is barbituric acid. Okay, it is an heterocyclic compound that is obtained. So this is the use of diethyl malonate in synthesis of acid, dicarboxylic acids, ketones, as well as the heterocyclic compounds. Thank you.